All right, guys, a couple things. There's 4 problems here that I wanted to go over with you that's not covered on the study guide that I did real quick in the other lessons. So you might see these on a test or in your weekly assignment for next week where this will be covered. Just wanted to give you an example of how to do it. So it says, find the measures of the sides of equilateral triangle FGH. And here's a picture of the triangle. So we know if it's equilateral, all the sides are the same length, right? So to know what the length of each of those sides is, I gotta know what y is. So to solve for y, since all 3 sides are equal, I just pick 2 of them and set them equal to each other. And it does not matter which 2 I pick, because at the end of the day, they're all equal, right? So I'm gonna set 2y plus 5 equal to 3y minus 3. You could have used 5y minus 19. Doesn't matter, you'll get the same answer for y at the end. Okay, so then to solve for y, I need to get rid of my smallest variable. Whatever I do on one side of the equal sign, I got to do to the other. 5 equals y minus 3, then I add 3. So y is going to equal 8. Once I know what y is, I can plug it into each of these, right? So here I have 2y plus 5, 2 times 8 plus 5. 2 times 8 is 16, and 16 plus 5 is 21. 3 times 8 minus 3. 3 times 8 is 24. 24 minus 3 is 21. And then down here, 5y minus 19, we know it's going to have to be 21. Let's just make sure. 5 times 8 minus 19. That's 40 minus 19, which does equal 21. So all 3 sides here are 21. We first had to set 2 of the sides equal, solve for y, then plug it back in. And then another problem similar to that, find the measure of the sides of isosceles triangle KLM with a base of KL. So an isosceles triangle is when 2 of the 3 sides are equal to each other. So how do we know which 2, right? Sometimes you can look and tell, sometimes you can't. But here it tells us that the base is KL. The base of an isosceles triangle is the one side that's not the same length as the other 2. So here, our base is KL, which means the other 2 legs or sides have to be the congruent sides, right? So to solve for the length of each of these, I got to solve for D. To solve for D, I can set these equal to each other. 12 minus D equals 4D minus 13. They're both the same length because this is isosceles. So then I just start solving for D. I add D to both sides of my equal sign. Then I'm going to add 13 to both sides of my equal sign. And then divide by 5. D equals 5. But it doesn't ask us to solve for D. It asks us to find the measure of the sides, right? So now I just plug 5 in for D. Here I have 5 plus 6, which equals 11. Here I have 12 minus D. 12 minus 5 equals 7. And so these aren't the same, which is good. So far, so good. These 2 are supposed to be the same. So this should end up equaling 7, right? So 4 times 5 minus 13. 20 minus 13, which does equal 7. So the length of our sides here are 11, 7, and 7. And you could just leave the picture like that. That's fine with me. Sometimes if it asks you if it's multiple choice, it might give you like KL equals 11, KM equals 7, and LM equals 7. Remember when we write a line segment, if we're talking about its measure, we do not write the line over the top. If we're just talking about the segment in general, we'll put the line over the top, but when we're talking about the measure of the line segment, we don't put the line there. So you can either write your answers out like this, or you can just leave it in the picture form, but I do have to see your work either way. Okay, and then the other, this video is a little bit longer, the other 2 are just alike. I have 2 examples here. You might see something like this. Find the measures of the sides of triangle XYZ, and then classify by the length of the sides, right? And all it gives us is the location of each of the points of the triangle, of each vertex. That's it. There's some triangle XYZ. We know where X is. We know where Y is. We know where Z is. Other than that, we do not know what this triangle looks like. Now, you could graph it on a coordinate plane. That's fine. But you're going to have some diagonal lines in there. So you're still going to have to use, drum roll, the distance formula. right? So to find the length of each side of our triangle, I'm going to use the distance formula. Now, to keep track of it in my brain, I'm going to kind of just sketch a little triangle here. X, Y, Z. So I know I need to find the length of XY, the length of YZ, and the length of XZ. I've got to find the length of all of those, right? I don't know what it's going to look like, but that's what I'm going to start. So I'm going to start with XY, these first two. And distance formula, remember, D equals the square root of X minus X squared plus Y minus Y squared. That's our distance formula. You learned it, you're going to have to use it, right? Okay, so here X is 3, Y is -2, X is 1, Y is -4. I'm not talking about this number, this letter. I'm talking about the coordinates, X and Y. Okay, so I'm going to have XY equals square root of X minus X, 3 minus 1 squared. Since I started with 3, I'm going to start with -2. -2 minus -4 squared. Okay, a minus and negative becomes a plus. And now I can just start simplifying, right? 3 minus 1 is 2. 2 squared is 4. -2 plus 4 is 2. 2 squared is 4. So I've got square root of 8. Now this is the most accurate way to list the length of the side, right? Square root of 8. So you can leave it like that. Sometimes when we're talking about a physical shape and we want to know the length of it, square root of 8 doesn't really tell us the length. So you can guesstimate it, or not guesstimate it, estimate it in your calculator. This is going to be 2.83. 2.83, but you do not have to go that far. This is more accurate, right? And really here, to classify by the sides, we don't really care what the sides are. We just need to know, are all 3 sides the same? Are 2 of the sides the same? Or are none of the sides the same? So you could just leave it here. You don't really need to know the measure just yet. All right, so I found XY. So I got that one, check. Now I want to find YZ. YZ equals, and here's my Y and my Z up here. So same distance formula, X minus X, Y minus Y. And then I simplify. When I minus a negative, it becomes a big plus sign. Square root of 1 minus 3 is -2. -2 squared is 4. -4 plus 4 is 0. 0 squared is 0. So I get square root of 4, which is also 2. Now, what this tells me is that I know it's not going to be equilateral because I already have 2 sides that are different. So what it's going to be depends on what this third side is. Will it be isosceles or scalene, right? So now I need to find the length of XZ in my triangle. Okay, so I have X and Z. It's my first and my last whatever coordinate points here. So X minus X, 3 minus 3 squared plus -2 minus -4. Simplify. 3 minus 3 is 0. 0 squared is 0. -2 minus -4 is -2 plus 4. -2 plus 4 is 2. 2 squared is 4, which gives me a square root of 4. Okay, so now I know 2 of my sides are the same. So these are the lengths of all 3 sides of my triangle. I don't exactly know what they are. I did change it here, so I kind of do know what they are. But I didn't have to. I just need to know they're not all the same, and they're not all different. 2 of them are the same, the length of 2 sides, which means this is an isosceles triangle. Isosceles, because 2 of our sides are the same length. Okay, we're going to do the exact same thing here. You can pause the video if you want to try it first. I'm going to work it out same exact way. So I have my little idea in my head of what my triangle looks like. I'm going to have side K, P, side PL, and side KL. So I got to find the length of each side, right? So for KP, -3 minus 2 squared, 2 minus 1 squared, and I start simplifying. -5 squared is 25. 1 squared is 1, so I get square root of 26. and I don't have to go further. I don't really care what this number is. I just want to see if it's the same or different as the other sides. Then I have side PL. So from P to L, 2 minus negative 2 squared plus 1 minus negative 3 squared. 2 minus negative 2 is 2 plus 2. 1 minus negative 3 is 1 plus 3. 4 squared is 16. 4 squared is 16. So this is square root of 32. Okay, so I know it's not equilateral. So now it's either going to be isosceles or scalene, depending on what this third side is. So the side is KL. So I have negative 3 minus negative 2 squared. 2 minus negative 3 squared. Anytime you have a double minus, make it into a plus. Negative 3 plus 2 is negative 1. Negative 1 squared is 1. 2 plus 3 is 5. 5 squared is 25. So I get square root of 26. So 2 of my 3 sides here are the same. This is an isosceles triangle again. Okay, if you have questions, let me know.